Hi everyone, in this video I'm going to demonstrate how to use your graphing calculator to solve exponential equations, the type like this where we can't easily make all of the different exponent terms here with the same base. So the first step I'm going to take is by using the Solver app. Solver is down here inside the equation option, so I'm up to equations here, and I type the entire equation as is, 16 to the power of x minus 3 to the power of x. Now I need an equal sign. The equal sign is down here on shift decimal point, and the whole thing is equal to 5. So I just press execute there. Now don't worry about the numbers yet. These are just the previous results that it was working on. In order to get this to work, we need to press solve. And here it is. It's searched and it's converged on this answer here. If x is 0.711, then the left hand side evaluates to 5 and the right hand side already is 5, so they're equal. So we can just simply give this as our answer here. We can say that x equals 0.711, and we are finished, we're solved, we're done. That's pretty straightforward. The Solver app doesn't always converge, and you would have noticed that I have a lower and an upper limit here. I can change those lower and upper limits. That's a really large negative to a really large positive, so it's searching a very large domain, but it still works nicely and it's quick. An alternative way is to use the graphing app. So if I go to the graphing app here, I've already entered the left-hand side of this function. Now to explain a little bit of what I'm thinking here, let me just say, what am I doing? I'm thinking to myself that the left-hand side of the equation that we were given is a function of x, and that function is, as we said there, 16 to the power of x minus 3 to the power of x. And of course, the left-hand side of that function will take all sorts of different values depending on the value of x. And we can get an idea of that by graphing them here. So let's draw that. Oh, beg your pardon, I need to press F1 to select that little highlight, wasn't there? So let's draw that. And this is just the left-hand side of the function, behaving nicely. I'd already set the view window to match. I might just move up slightly, a little bit there. So now how am I going to find when this equals 5? Well, when the y value equals 5, there it is. I could do it like this. I could go gsolve, and then I could ask for an x calculation, and it says what y value I'm interested in, a y value of 5, and then it highlights the point and it tells me, unsurprisingly, when x equals this number, y equals 5. Now I think there's an even more elegant way to do this. If we exit back to here, and if we just move down here, let's think for a moment about the right-hand side of this function. Sorry, let's put this as an equation. The right-hand side of this function, it's not a function of x, it's just the constant value 5, isn't it? Now, there's no reason I couldn't think of this as some different function, g of x equals 5. So really, what am I doing? I'm thinking of my original equation as two different functions, f of x on the left of the equals, g of x on the right. And I'll plot a second function here. So I've got two different graphs going to appear. The blue one is f of x, the red one, g of x. Remember, if it's a constant, it's a horizontal line. Now the intersection point would be the place, so I can go gsolve and then intersection. The intersection point is where the x and the y values of both functions coincide. There it is. There's our solution. So that's just a couple of quick ways that you could use. How would I finish this one off then? Well, I would say something along the lines of when x equals 0.711, f of x equals g of x, And that's sufficient justification for stating our solution. Definitely mention the use of the graphic calculator as part of your work. That's all for now.